Dear students, now we are going to see the governor problem, Hartung type governor problem. Right, you see this problem in a spring control governor of a Hartung type. The length of the ball and sleeve arms are 80 mm and 120 mm respectively. The total travel of the sleeve is 25 mm. So the total travel of sleeve means the up and down motion of the sleeve is 25 mm. The mid position of each spring is compressed by 50 mm. So the initial compression of the spring is 50 mm. The radius of rotation of the mass center is 140 mm. Each ball has mass of 4 kg and the spring has a stiffness of 10 kilonewton meter of compression. The equivalent mass of the governor gear at the sleeve is 66 kg. Neglecting the moment due to the revolving mass when the arms are inclined. So determine the ratio of the range of speed to the mean speed of the governor and also find the speed in mid position. So you see this diagram, a simple line diagram of a Hartung type governor. So this axis of the governor. So this is the simple bell crank lever. So this is a lower arm, this is a upper arm. The lower arm length is x, upper arm vertical arm length is lower arm length is y, vertical upper arm length is x. So here the vertical arm, the upper point has two forces. One is a spring forces in right hand side and the left hand side is a centrifugal force due to ball. Right. So the lower arm, the left right side point. So the sleeve is attached. So it is mg divided by 2. Right. So you write the given data. So given data is very important one for solving the problem. First, what is x? So it is 80 mm. Then y is equal to 20 mm. So 80 mm. Y is equal to 120 mm. So the initial height. So height of the sleeve travel h is equal to h1 plus h2, that is equal to 25 mm. Right. So initial compression of the spring, that is equal to 50 mm. Right. So radius of rotation, that is equal to 140 mm. So 140 mm. Right. The spring constant, yes, small s is equal to 10 kilonewton meter. Then mass of the ball 4 kg, the mass of the sleeve 16 kg. Right. So here it is a 16 kg. So in that solution, so you should find out the initial mean speed of the governor you should find out. So in that solution, right, first one, you should find out the mean speed of the governor. Mean speed of the governor is a very important one, that is n1 you should find out. So take the moment about O point. So f c into x, that then s into x plus mg by 2 into the horizontal distance y. So what is fc? Fc equal to mr omega square. So here m, you know that it is 4 kg, into r you know that is a 0.14, that is 140, it is 0.14. Then omega square you doesn't know it. Right. Next you find out the s. How do you find out the s? So the spring stiffness, that is equal to spring force divided by initial compression of the spring. Right. So that is equal to 10 into 10 to the power of 3 equal to capital S divided by 0.05. Right. So therefore S is equal to 500 Newton. You are getting that. Capital S is equal, that is spring force, you are getting that 500 Newton. Now substitute all the values, known value in this equation. So m 4 into 0.14 into omega square into the x value. You know that x value is equal to 80, is 0.08. That is equal to, what is the s, 500 into 0.08 plus, that is 16 into 9.81, so divided by 2 into the y value. You know that it is 0.12. So from the all the from this equation you find out the omega 2, that is 1103. From that you should find out the omega equal to 33.2 radians per second. So that is equal to 2 pi n divided by 16. So now find out the n is equal to, so 317 rpm. You are getting that, right? So mean speed, another formula is n is equal to n1 plus n2 divided by 2. So another formula is n1, right? Next you find out the range of speed of the governor, right? You should find out the range of speed of the governor, right? So the second one, the range of speed of the governor, that is n1 and n2, you should find out. So first you should find out the n1 for the minimum minimum speed. So you see this diagram, this is a simple line diagram of the Hartung governor at a minimum position. So this is a lower arm, this is the upper arm, distance y, this is distance x, right? This spring force towards rightward direction s1, centrifugal force towards leftward direction fc1. So the distance between axis of the governor to the this ball point, that is r1. So the ball point to the this vertical pivoted, this O point vertical line, that is a1. So the total distance is r, right? So now, so this distance, so the vertical distance from O point to this ball point is x1, the horizontal distance to O point to this point y1. So the slip force mg divided by 2, right? That is called as r1 force. So the distance between the distance travel of the arm in downward direction is h1, that is the height of the governor moving downward direction, isn't it? So this is the notation of the minimum notation of the various parameter in the minimum position. Now you have to find out the n1. So how do you find out the n1? You should take the moment about the particular point. So take the moment about the O point. So fc1 into x. So fc1 into x, that is equal to s1 into x plus mg divided by 2 into y. So now you find out the n value from this equation. You know that fc1 equal to m r1 omega 1 square. From omega 1 square you have to find out the n1, right? So now what are the things you should find out first? So r1 you should find out, r1 equal to r minus h1 into x divided by y, right? So how this equation comes? So there is a relation r minus r1 divided by h1 equal to x divided by y. So from this equation right? So r, you know that 0.14 minus h1. What is the h1 value? So you know that h is equal to h1 plus x, so that is equal to 25 mm. So h is equal to h1 over 25 divided by 2. So 0.025 divided by 2 into, you know that x value 0.08, so divided by 0.12. So from that r1 equal to 0.132 meter, you are getting that. So in this equation, so m you know, r1 you know, w1 square we doesn't know. So next you find out the s1. S1 you have to find out. So how do you find out the S1? S1 equal to initial compression of the string minus R minus R1 into spring stiffness. So initial compression of the spring 0.05, that is 50 mm, into R value 0.14 minus 0.132, that is R1 value, into initial compression of the spring 10,000. So from that you can find out the S1 equal to, right, 420 Newton. You are getting that. So from this you can calculate the other values, right? So in this equation, S1 you know, X you know, what is the other value? So M you know, G you know, then Y value you know. Now you substitute all the values in this equation, so you are finally you are getting the values. So FC1 that is equal to M R1 omega 1 square into X, S1 into X plus mg divided by 2 into y. So what is the m value? So m value you know that it is 4 into r1 value 0.14 into omega we doesn't know, right, into x value is nothing but 0.08 equal to s1 value you know that 420 into the x value 0.08 plus m value you know that 16 into 9.91 divided by 2 into the y value 120 mm, so 0.12. From this you can find out the omega 1 square, that is equal to 1019. So that is equal to 2 pi n divided by 16, right? So root of, right? So n1 equal to, you are getting that n1 equal to 305.5 RPM. You are getting that. Solving that equation, you are getting that 305.5 RPM. You are getting that. So next you find out the N2 value, that is the maximum position of the governor, right? So you should find out. So second one, N2 maximum position speed of governor. Okay, you should find out. So taking moment about the O point, so FC2 into X, right? So very simple one, that is equal to S2 into X plus mg divided by 2 into y. So now how do you find out the, so FC2 equal to mr2 omega 2 square. Now you find out the R2 value. How do you find out the R2 value? It is very simple one. So R2 minus R divided by H2 equal to X divided by Y. So from that R2 equal to, you know that R plus H2 into X divided by Y. So you know all the values 0.14 plus H2 value you know that 0.025 divided by 2 and 0.08 divided by 0.12 you are getting. So R2 value, so you are getting that 0.148 meter, that is 148 mm you are getting that, right? So next you find out the S2. S2 is equal to, you know that initial compression of the spring plus R2 minus R1 into spring stiffness. So initial compression of the spring, that is equal to plus 0.05 into R2, you know that 0.148 minus R1, R, this is not R, this is not R1, this is R, 0.14 into 10,000. So S2 equal to, so what is it is equal to, you are getting that 580 Newton, right? So you know all the values. Now substitute in the equation. So in this equation, write m r2 omega 2 square x equal to s2x plus mg divided by into y. Now substitute all the value. So m, what is the value for m? You know that 4 into r2 0.148 we find out. Then omega 2 square equal to, what is the s2 value? 580 into x 0.08 plus 16 into 9.81 divided by 2 into y value 0.12, right? So from this you can find out to omega 2 square equal to 1178. Then what is the value for omega equal to omega 2? That is a 134.32 radians per second. So that is equal to 2 pi n2 divided by 16. So from that you have to find out the n2 is equal to, right, n2 is equal to 33 to 7.7 rpm. So therefore range of speed equal to n2 minus n1, that is equal 327.7 minus 305.5. so that is equal to 22.2 rpm, right? So that is called as a range of speed. Ratio of range of speed to mean speed you have to find out. So ratio of range of speed to mean speed equal to, right, n2 minus n1 divided by n, right? So 22.2 divided by 317, that is equal to 0.07, that is equal to 7%. So this is the range of speed to the mean speed of the governor. Thank you.